Hi and welcome to this session called Machine Learning Yesterday, Today and Tomorrow at H&M Group. My name is Errol Koolmeister. I'm the Product Area Lead Engineer for AI Foundation. In order for us to create the future, we must understand the past. That is why I will briefly go through the H&M journey together with the AI journey we've seen in the world so far. This is of course the high-level overview, but important to know if we later will try to understand where we are going. Of course, this timeline starts in the 1950s. That's because the term artificial intelligence was coined in 1956 at the Dartmouth College Summer of AI Conference, which was organized by John McCarthy, Marvin Minsky, Nathan Rochester of IBM and Claude Shannon. McCarthy coined the term artificial intelligence in that conference. But of course, there was a lot of work prior to that as well. A lot of the early math was done, centuries ago, before that time. But let's, by the sake of simplicity, start in 1950. And I just wanted to show that it's been a bumpy ride from the 50s to these days. And this is basically because they started talking about it in the 50s. They were limited capabilities, so we couldn't really do much by then. Then expert systems come into play, became really hot in the 70s, early 80s, but the results weren't that good. So, the second AI winter came. Then in the early 2000, 2010-ish, there's been a lot of academic work on the side, of course. This became more mainstream. You started seeing the launch of Spark, Hadoop, etc. So all of a sudden this became more commodity resources. And we really started to see the machine learning, deep learning, and big data wave taking off. And that leads us to today. So what is the H&M machine learning story? Of course, H&M was founded in the mid-1940s, and back then there were no machine learning to speak about. As you heard in the previous slide, all of this really kicked off in the 1950s, and we haven't seen a great big evolution up until these days. Erling Persson usually said, "We'll be where the money and the bags are." That's why H&M can be found at many leading shopping hotspots in the world. Oxford Circus in London, Ströget in Copenhagen, Karl Johan in Oslo, Hamngatan in Stockholm. But hotspots mean high lease costs. However, we avoid actually owning any retail property so that we can remain as flexible as possible. After all, a good location can suddenly turn pear-shaped. Street plans may change as well as the flow of shoppers. That's why it's important to actually follow and track the data. Already from the early days, H&M had good control where the money and the bags were. This slide shows you one of the world's most famous hotspots. I'm going to give you 1 or 2 seconds just to try to get yourself acquainted where it could be. Any ideas? If you guess Manhattan, New York, then you're of course right. And just guessing by this picture, where would you find the H&M stores? Of course, where the lights are. Follow the money and the bags. So the H&M machine learning journey actually really started quite late, I must say. It wasn't up until 2016 that we started and initiated the early proof of concept, where we really tested our advanced analytics appetite and applicability of the ideas that we had. In 2017, we continued to build the first proof of concepts and rolled out pilots across the world. We defined the organization and the capability needs that we wanted to have. And we also established a very modern IT and data environment, fully cloud-based. In 2018, we actually became a function within H&M, so no more project or program. We were the new function within, I think it was 10 years. So we started rolling out the successful pilots that we have into the core business side, started setting up the ways of working, team and governance. So I would say in 2019, that's the year where we actually started to industrialize at scale, where we really were focusing on the scalability of the use cases that we had, where we actually started rolling out and increasing the data and algo-driven retail business, and we were supporting across the entire value chain. This year, 2020, we have focused so much on actually getting into the next step. The preparation of reshaping the H&M organization to be able to work fully data-driven is a struggle, no, I would say a passion that we have been spending the bigger part of these years on. That leads us up to today. Brief introduction as I promised you. So let's immediately start deep diving into where we are today. As I mentioned a few slides ago, we are covering the entire value chain. We are doing everything from design buying support with assortment quantification, fashion forecasting, into production, where we actually have teams with no established use cases, looking on how we can support the productionization of the clothes that we are ordering, logistics, where will the clothes go, which store will actually have a data-driven assortment, and then also in the sales cycle, making sure we optimize the reduction and discount setup within H&M across the world. And then in the marketing perspective, in the end with the personalization, supported by the H&M advanced analytics landscape. So covering everything, but we are not satisfied with that. We want to take it to the next step. What we have understand is that in order for us to be able to develop great technology and supporting machine learning, we have to understand the process. Because if we don't understand the process, we'll just go out and build a bunch of very specific software for supporting machine learning and AI use cases in these different use cases. So we have initially spent a lot of time on mapping the process. What is model development? What is model usage? How do we actually work with model and data versioning? Taking over this code base that we did in 2018 and structuring it so we can get a better software development principles around it. In the end, it's really about mapping the process into technology to support the people that needs the result. And of course, if we then understand this process, it becomes much easier. So for instance, mapping Databricks as a notebook environment and potential deployment and building environment for data scientists to go into, making sure that they are able to use it whenever they want, they can scale up and down, they can get the data from the data lake store, and when it's time actually handing that over to a machine learning engineer, which can use either a PyCharm with a lot of code in the back end and integration sides, or having the other tool IDEs that are available in H&M. Utilizing Docker to be able to actually start and building these things out on your desktop to be able to go to cloud. And then later on, having those orchestration options with Airflow, Databricks for building, Data Lake Store for actually storing intermediary data, and machine MLflow to be able to track and log the metrics in the process. And then of course, in the end, if you're running tuning jobs, utilizing PyCharm as kind of the getting the results back, being able to tune it, Azure Databricks to kind of search through the entire grid space that you want to go through. And then when you have your model, utilizing Docker as you did on the implementation side, having that environment all set up and nice and smooth. So you can either hand that off to offline model prediction, which looks very much different than online model serving, because in there you might need Kubernetes online all the time with a container registry that automatically can pick up on all the changes in the code and deploy it again on Kubernetes. And then of course in the end, having some sort of home-built model monitoring tool so you know when there's data drift or model drift in all of your processes. A set of different principles. And these architectural principles are more like guidelines, because even though many of the machine learning use cases that we have similar processes, they have a component of reusability, none of them are 100% exactly the same things. And you will not have the same engineer working on these problems all the time. So it's better to have more reference architecture where people understand what it is we want to build, where we kind of push for these principles and follow them up, rather than enforcing and putting people into a box having to use a certain technology. So for our architectural principles, it's about the separation of concerns, where you understand your process and this is what you're going to do, then you'll separate that. It's also about stateless, having infrastructure as a code, having configuration files, so you can put the machine up and then you can turn it off. No unnecessary costs. Automation, important topic, and I'll get back to that. Making sure things are cloud native. So if they run in the cloud, that means we don't have to actually worry about the maintenance side of things. If we need a new server, yes, we can of course set it up very fast using the cloud-based setup. and minimizing server as much as we can. Serverless obviously means that we need to be very aware that we use configurations, that we store apart, that we focus more on the process and the files rather than actually writing code that's closely entangled. So from that perspective, we talk about automated ML development. And I just put this slide in because I wanted to show how that might look like and where we are today. So in many of our use cases, when we have a model, for instance, we commit that or write that in PyCharm. We commit that via Bitbucket, of course. We could utilize any Git technology, but for now we use Bitbucket. We push that and Jenkins picks it up. Jenkins then run automatically code static checks, unit tests, package checks, etc. And when all of that is done, that will trigger a pipeline. So we might have a vacant Databricks cluster, or we might use hot pooling to pull that up. In there, it's going to be all the code bases going into DBFS, and then running the model, job execution, having scalable infrastructure. So it goes up and down depending on the workload. Logging all the model information, and then when the model is trained, it will shut down the cluster. Of course, before that, I'm hoping most of our use cases have committed the model into a model repository. That goes into Jenkins, and Jenkins then builds a container image. That container image is being pushed into a container registry. Kubernetes automatically detects that there's a new version, can pick it up and deploy it. So automatically happen in the background, having an automated ML development side. Of course, there's still a lot of manual processes in this. But as you will get acquainted to, this process really is about software development, right? So that takes us into the next slide. One of the major things that we have encountered so far is that you do a lot of software development. But what we also realized is that we need to make a difference between traditional software development and machine learning, because machine learning engineering has another perspective. It has another goal. It is not just about meeting a functional specification as in traditional software development. It's about optimizing a metrics. You want to get that accuracy as good as possible given the current circumstances that you can. And the quality of this is, it's not just code dependent as in traditional software development. It's about data. It's about the input data and the parameter tuning. How good can you do it and how cheap can you do it? Honestly, it's not just about throwing a lot of computer on it, because if you do that, that will become really expensive. And then the stack that you do these things, we try to minimize it, but we realize that we can't, because it's about getting the best results, which means you need to compare and combine many different libraries, models, and algorithms for the same task. And you need to have them competing towards each other, multi-arm bandit strategies, canary deployment, etc. But in traditional software, it's really about picking one technology and then stick with it and meet your functional specifications. So what we realized is that machine learning requires a fundamentally, I'm going to repeat that, fundamentally different deployment approach than traditional software, which grows from building web applications. Our complexity is so much higher. It is really about understanding that the model aspect is just like 5% of this process. Everything around it is an engineering aspect. How will I get the data? How will I verify it? How will I keep track of resources? How will I extract features in a good way? How will I configure things? How will I handle the processes? How will I serve it? How will I monitor it? So machine learning engineering, what we have established today, is so much more than traditional software. It's so much more than data science. What we have now in front of us is the next generation of jobs. And machine learning engineer is so important. The machine learning engineering, as we have established it today, it's really about keeping track of all the software responsibilities within the machine learning projects. I think that the data scientists are extremely important in getting the right models, but the machine learning engineer is so important to actually get the value in the end. How will we do the data collection and preparation, the feature engineering? Training of our models, evaluating, model maintenance, monitoring, model serving, and deployment. All of these requires different type of skill sets. And as a machine learning engineer, you need to master all of them to be a good one. Then let's start talking about the future. Let's talk about our foundational capabilities within machine learning at H&M. We have done so many things in so short time at H&M, really taking us to the next level. But what we realize now is that we've proven the value in use case by use case. And for us to be able to reach the next level, we need to industrialize and scale machine learning across H&M. That means that we need to make machine learning available across the H&M group. We need to facilitate scalability and specialization, because we can't hire 1,000 people and just have them go out and create great machine learning products. We need this facilitation and have other people actually implement it. We need to continue building world-class machine learning products, engines, and core components. The question is, how will we do that? The how is really about establishing a product organization where we will have different type of product teams facilitating the AI and machine learning process at H&M. We will talk a lot about ideation and incubation of value-focused AI products. It's really about getting the value. It's not about having research project for us. It's about testing. Creating foundational teams to facilitate the scaling of the AI capabilities, creating a platform team, creating best practice team, creating cooperation teams, etc. We don't have all the answers yet, but these teams will be able to help the rest of the organization. And also focus more on engines to support the AI-based product teams. We will have reusable components where product recommendation engine can support multiple teams wanting to implement product recommendations rather than the other way around where each team creates their own product. So, as I mentioned before, for us it's about focusing and learning from those that have already gone through the journeys. And if you look on the giants in this space, what have they done? Well, they've created machine learning platforms to manage the machine learning lifecycle. And I think that's the direction we will start going as well. We need to ensure the traceability at scale through automated versioning and restoring across the development process, making sure that the process we understand actually is implementable into the different projects that actually need this type of support. Having these platform teams, creating it out of the box solutions. For us, it's about getting behind and creating a vision on where we want to go. And that vision is really about creating reusable components, going from use case specific components, where each use case are responsible for the entire end-to-end process, into where we create more component libraries for reusability across use cases, where use case number 1 might have demand forecasting and a returns module, and use case number 2 might have a returns module. And what we want to do is actually make sure that we gather this and reuse the things that we build so we don't create too much waste. And if we can do that, I think we really can scale, and we don't need 1,000 people to actually accomplish this. We need more specialists creating the tools, technologies, and models that we need in order to take the next step. So in the end, what does that mean for us? It means that we need to focus on creating these capabilities that I mentioned in machine learning, because it's not just about technology. It's about capturing the knowledge and managing it. It's about training and developing not just our people in machine learning, but entire H&M. It's about focusing on the right machine learning projects. It's about focusing on exploration and research as well, making sure we get the research that we need, but don't spend time that's waste. We need to focus on the ecosystem and vendor management. Who should we cooperate with? Because we can't do it all by ourselves. What type of development tools and infrastructure should we build for the organization? How do we manage and foster expertise within all of this? And how do we make sure that the risk and ethics sides are not forgotten? Because we know that there might be biased data. How do we keep track of it? How do we also quality guarantee the things that we deliver? How do we make sure the end user can actually trust the models and the results? And how do we take this specific way of working? If it's coming from academia with long research cycle, how do we make it become agile, and how do we fit into that process? Those capabilities we need to create within machine learning, not just the technical aspect of things, but the people side, the knowledge side, etc. So to summarize, how we will democratize machine learning and scale it across H&M? We need to bring tech closer to business, making sure we capture the right requirements from our stakeholders and that they are aware of what we are doing. We need to expand and scale machine learning in the entire organization. We need to professionalize our AI and machine learning capabilities, as I've spoken about here. And we also need to leverage reusable components. Our vision is really that by doing this, we will be able to become an industry leader in fashion by 2023. Okay, we have come to a road's end in this presentation. Thank you so much for taking the time and listening. Any questions, just shoot me an email, errol.koolmeister@hnm.com, or add me to LinkedIn and we can start a dialogue. Thank you and goodbye.